Welcome back, Pre-Calc. We are going to talk about Unit 5, Section 6, with sum and difference formulas. So here's the thing, is every year I teach you, somebody does this wrong. So I'm going to try and take this a little different of an approach where I'm talking about sine of 45 degrees plus 60 degrees. Because what's really happening here is that we want to add the angles first. You can see that the parentheses in the order of operations means we need to add those first. So every year I teach you, somebody wants to distribute sine in there. And I get why, because they're looking at that and saying, well, I know the sine of 45 degrees is, well, it's the y-coordinate, it's the root 2 over 2. And then on this one, at 60 degrees, again, it's the y-coordinate, it's 1/2. Nope, it's root 3 over 2. Anyway, so what they'll do is they'll say, well, if I can split this up and take the sine of each angle, then I'll get the right answer. Now, the issue is if we really add these angles together first, and we do 105 degrees, well, then that's actually over here into this quadrant. And so if you think about the y-coordinate, well, the highest that the y-coordinate could ever be is 1. So if you were to try this problem out, and I'll just grab a calculator real quick and do it that way. Make sure you're in the right mode. We are in degrees because the problem gives you the degrees. So if you did sine of 100, sorry, I wanted to do sine of 45 first, plus sine of 60, we get an answer that's bigger than 1. And what I said earlier was still true if you wanted to write it as root 2 over 2 sine of 45 plus, oops, I did this wrong, root 3 over, there we go, I fixed it. That's where that value comes from. But the problem is that sine of one angle should never be bigger than 1. So this was, I already forgot what it was, 1.573. But that doesn't make any sense because sine of 105 degrees, if we follow the order of operations and we add the angles first, we should only have sine of 105, which is 0.966. This answer is the only one that makes sense. So I'll just write it that way. Sine of 45 degrees plus sine of 60 degrees does not make sense. Because we are doing the order of operations, so we do parentheses first. And sine of any angle, I'll just call it theta, in degrees must be, well, let's put an absolute value, must be less than or equal to 1. Or it could be a negative value. So if this notation is new for you, it's just saying that sine of theta in degrees must be smaller than 1 but bigger than negative 1. So that's why we need a new formula, a different formula that actually explains what sine of 45 plus 60 is. Now, I have made a video that actually explains this, and I may have explained it slightly different. But for our class, for our purposes, you can just write this down, or you can use Google trig identities. And you'll find a long list of formulas, and one of those is right here. I can't remember if I did the double angle formula in the video or the sum or the difference. I could easily go back and look, but so could you. So the whole premise of this is understanding that if I ask you to do sine of 105 degrees, well, 105 degrees is not on the unit circle, but 45 and 60 are. So 45 plus 60 is the same as 105. So the premise is that you can follow this pattern where A and B are just angles. So this is the same as sine of A represents the first angle, so 45 degrees. Cosine of B, the second angle, 60 degrees, plus cosine of the first angle, which is 45 degrees, and then sine of the second angle, which is 60 degrees. And that's why, knowing the unit circle, you don't even need a calculator to get this answer. I may go to a calculator here shortly, but if you recognize, so again, 105 is somewhere over here. This is 60, this is 45. The 45 is easy because they're both root 2 over 2, root 2 over 2, whether it's sine or cosine. So sine of 45 is root 2 over 2, cosine is root 2 over 2. And then the 60 degree angle is 1/2 root 3 over 2. So cosine is 1/2 plus from the formula, and then sine is root 3 over 2. So as you multiply, and remember to multiply fractions, it's just numerator with numerator, denominator with denominator. So they both have a denominator of 4, and on the numerator we have root 2 plus root 6. And what I'm saying is that should be equal to that 0.966 value that our calculator said earlier. And let's go to a calculator and just verify that. Let's see, there's my calculator. Okay, so alpha, make my fraction, root 2 plus root 6 all over 4. You get the same exact value, so we can do this. We can do a lot of different angles now that do not have to be on the unit circle. So again, I'm not going to expect you to memorize these formulas. I'm even giving you this formula. If you feel inclined, I made the other video that explains at least one of these or a slightly different formula, but we'll get to that when we get to it. It's easy for me to remember because if you think about these two formulas for sine, notice that the difference is subtraction here. So it becomes a subtraction. If you think of it as adding the opposite, it does make sense, but you have to do one more thing. You have to know one more fact that we have not learned yet as to why it just changes one, the plus to a minus, and it doesn't change the other. But we haven't learned that yet. So here's the thing. Is sine of 15 degrees, we can get the exact answer. That means we do not need a calculator. So there's no need for a calculator. What you have to do, though, is think about what's another way that you can write 15 degrees using two angles that are on the unit circle. Now, there's a lot of correct answers. I like to use the easiest ones. So as I'm looking at that, I'm thinking, well, I guess what I'm trying to boil it down to is we want to use something like 30, 45, or 60. And don't forget, I know I just did one that's addition. We can also use subtraction. Is it true that 45 minus 30 is equal to 15? Yes, it is. So go to the difference formula, and anytime you see A in the formula, you're replacing with the first angle, which is 45 degrees. So this would be equal to sine of 45 degrees, cosine of the other angle, which is 30 degrees, minus cosine of the first angle, which is 45 degrees, sine of the second angle, which is 30 degrees. And all you need to know is the unit circle. And I just drew it right here. I guess I should add in that the 30 degree angle is root 3 over 2 comma 1/2. So you can use these four ordered pairs, or I should say four coordinates of the two ordered pairs. And remember, 45 degrees is always the root 2 over 2. So if you forget those ones, they're not that bad. But cosine of 30 degrees is the x coordinate now. And sine of 30 degrees is the y coordinate. You can see how it slightly changes those values up there. But again, the denominators are the same. 2 times 2, 2 times 2. So we can combine them together. Root 2 times root 2 is root 6. Root 2 times 1 is root 2. This is your exact answer. Now, if you have access to a calculator, you can double check that you have the right answer. And all I would do is type in sine of 30 degrees. So that's, oh, no, that's not what I wanted. I wanted sine of 15 degrees. It's a very ugly decimal, but I can make a fraction that says root 6 minus root 2 all over 4, and it's the same decimal, so I know I did it correctly. The exact answer I got matched the approximate answer. So this is a way to check your work. This is not algebraically showing it, though. And to me, the most difficult part is thinking about what two angles can add or subtract to give me that value. Now, the directions here are kind of nice. Like here, it told you to think of a difference. Here, it told you to think of a sum. I don't think in the future I'm going to tell you what to think about, but I would say that thinking about a sum would make perfect sense. Now, there's a lot of correct answers, so don't just do what I do. You can try this on your own and see if it matches mine, or you can think of something slightly different. But if you think about the unit circle, maybe I'll just draw that real quick. A unit circle, well, 270 degrees is down here. Well, 285 is going to be a little bit bigger than that. So maybe what you could think about is, if you were thinking of, I don't know, 235 degrees, could you easily add a number to 235 to get that 285? And there's nothing wrong with just guessing and seeing. So I'm just pulling up a calculator. Is it 285 minus 235? Well, that was wrong. I don't even know what I was thinking, because 235 is not on the unit circle either. Maybe what I was thinking of was 225. And if you're sitting there and saying, well, how did you know 225 was on the unit circle? Well, 225 is 45 more than 180. So it is on the unit circle. I don't know why I was thinking 235. That was just wrong. So I'm going to go back and change it to 225 plus 60 is equal to 285. 225. So that was wrong. So this is kind of a teachable moment that even your math teacher sometimes makes silly mistakes like that. Like, I know 235 is not in the unit circle. I just poorly added 45 to 180. Anyway. And this is not the only correct answer. You could have done, I think you could have done 45. Let me just give you another example. If you did 285 minus 45, I believe 240 is on the unit circle. So 240 plus 45, maybe if you even subtracted off 30, 285 minus 30, there you go. I believe that's on the unit circle. Anyway, there's a lot of different answers here. The whole premise, though, is then you can go to your trig formula and say, okay, sine of my first angle, cosine of my second angle, and then plus cosine of the second angle. Cosine of the first angle. I forgot to put my degree, and then sine of the second angle, and I'm running off my sheet, but there's a little degree symbol. I'll move it so you can see it. Now, you also might be thinking, well, why did you do the 45 degree? Why did you like that one? I like it because it's always root 2 over 2, root 2 over 2. The only thing is, in the third quadrant, both of those are negative. So it's negative root 2 over 2, negative root 2 over 2. So then I just need to go to my unit circle and say, oh yeah, cosine of 60 degrees, that's the 1/2. I get plus here. Right here's the root 3 over 2. And now I can do the math. It would be negative root 2 minus root 6. That should be your exact answer. And it should make sense because sine is negative in the fourth quadrant, which is where 285 degrees is. I'm just sharing the answer key in case anybody wanted to do the problem slightly different. And notice you factor out a -2, which you can.